everyone. My name is Hyunjoon Kim, CEO and co-founder of SqueezeBits. We are literally squeezing AI models for efficiency. So today, let me go directly to our product and so on. So we are basically bridging the gap between AI service startups, companies, and hardware vendors so that they can achieve maximum efficiency itself. So we are not building our agents by ourselves or train our LLM models by ourselves. Rather, we help them deploy their models on cloud or on-premise environments for better efficiency. So we provide two different products here. Left one called OwLite, and the middle one Fits on chips. And also we do the service consulting services. Why we are doing this? Because NVIDIA is always saying that they've achieved like 1,000 times performance improvement over the last 8 years, 10 years or so. But if you really look into the numbers directly, precisely, and we can find that they're assuming users are quantizing or pruning their AI workloads for their GPUs. So in other words, if you are not doing those kind of quantization, pruning, and so on, you are not optimizing the model to fit in NVIDIA GPUs, you are not actually exploiting the full potential of those devices. So that's why we are helping our customers. And yeah, that's it. So the first product, today I'm going to introduce two of our products. The first one is for model quantization toolkit itself. So I know there are a bunch of tool chains or softwares for model quantization and compression. NVIDIA TensorRT engine, they do have their own pipeline for model optimization. But we help people to do that more easily and for better performance itself. So it's called OwLite. Basically, it consists of two components. The first one is Python package, and the other one is web-based GUI. The reason why we have built in this way, especially for the Python package, is that in most cases, other tool chains requires users to learn or write a new code for this kind of pipeline or process. That's very difficult and very not happy with those kind of pipeline. So users want to stick into their PyTorch ecosystem. That's why we have built this Python package. And you just need to install this package and import in your existing script. And adding a few lines of code, converting the PyTorch model with our convert API, then it will automatically convert the baseline PyTorch model to quantized version of PyTorch model. Since it's still in PyTorch format, you can reuse your pre-existing training code, evaluation code, forward, backward, gradient updates, whatever it is. You can reuse all of them for evaluation and quantization over training and so on. So that is the strong part of this package. And it's also connected to the web-based GUI, where you can see how the model looks like and also see the profiling results, layer by layer profiling results with the visualizations and compare or management for various experiments and quantization configurations. So we are saying that this toolkit is the easiest way to use TensorRT over quantization. To be more specifically, TensorRT over quantization aware training stuff, because we support PyTorch natively, and also it's very easy to use the quantization over training, because in most cases, quantization process is like, okay, I have my PyTorch model, I have converted to ONNX, and when I compile the model to TensorRT engine, I can apply post-training quantization and so on. But if you are not happy with that TensorRT engine, you have to manually modify the PyTorch graph and calibration and so on, and compile it again and see what happens. And those kind of cycles are very exhausting. So that is very easily supported. You just need to convert your baseline model to quantized version of it and just run the training script which you already have, and for just one or two epoch, and you will see the performance recovers. And we also support multiple precisions, formats, and quantization algorithms for each layer customizably. So it's very flexible and efficient, man. So yeah, just as mentioned previously, users have to define the PyTorch model, convert it to ONNX format, build the TensorRT engine, see what happens. If you're not happy with the performance inference latency or so, you have to manually modify the PyTorch model graph and then convert it again to TensorRT engine, see if you're satisfied or not. And then these kind of cycles have to be done repeatedly. But with our toolchain called OwLite, you can do it very seamlessly. So let me show you the, yeah. So, we have free version of it, which is mostly very powerful. You just can't do benchmark on your device itself. So you can try different configuration, whatever we support on our clouds. So we currently support L40 GPUs and 86,000 and so multiple devices. So you can manage multiple projects here. So I have a lot of example projects here. Let's see. So for example, ResNet 18, old one. But if you convert the baseline model itself, it first visualize how the model looks like. Familiar with this, ResNet 18 basic model. And down here, you can also see which part of the model is actually bottleneck in terms of latency and so on. So here, I know that this part, when I click this, it's highlighted here. Okay, the first part is bottleneck in terms of latency in our model. So definitely we need to compress, quantize, or this node. On the other hand, if you see the least time-consuming layer, which is the last layer, so I know that we don't really need to compress this kind of layer. So based on these insights, you can click, find some configurations. Okay, I'd like to try integer 8 precision quantization with different configuration and so on, and save the change for configurations. You can do each one by one, or you can also try, okay, I want to quantize all the convolution layers at the same time with same configurations. And you can also find some layers with the same shapes, or you can drag some part of the block and apply the quantization to all of these nodes. But most of our users do not want to do it by their hand manually. So we support a function called recommended setting. So if you click the trust me button, we propose a good starting point of the quantization configurations. So if you look at this, for example, this residue addition layer, which is just element-wise addition layer, it's better to not quantize one part of this input and keep it in floating point 16 precision rather than quantize both of the input to integer 8. Because if you really consider about the kernel fusion of TensorRT engine itself, it's better to not quantize both of them in terms of latency. So this kind of stuff can't be done by human in the loop. So that's why we support this kind of recommended setting. So if you save this configuration and go back to your PyTorch code, and with the conversion API, just describe that I want to quantize the model with this kind of configuration called experiment name temp, then the API will automatically convert the baseline PyTorch model to quantized version, which follows this kind of configurations. So you can try multiple evaluation in PyTorch level very easily and see in this dashboard or experiment list, you can see how the model size changed, latency improved, or we also provide any kind of logging functionality API, so you can log anything you want in this dashboard. So you can try different configurations and find out the best configuration you want in terms of latency and model size and accuracy, whatever it is. So there is some also visualized toolchain for comparing some experiments. But anyway, you can try different configurations and get your best ONNX version, ONNX format, or TensorRT engine itself. So we provide a lot of experiments here. And yeah, we also do open source some experiment examples for different tasks and different models and so on. So you can easily try out your similar models here, or you can try following this kind of examples. So yeah, we do have free version. You can use all the functionality for free version, but you can try only with specific GPUs on our side of clouds. So yep, looks like that's enough for the introduction of OwLite. And then, so that one, OwLite was for more likely TensorRT-compatible models for traditional computer vision tasks or BERT-type models and so on. And this one, the second one, called Fitron chips, which is totally free. You can just sign in and use it. It's more for LLM kind of autoregressive model support. So if you are running Stable Diffusion or TensorRT LLaMA or those kind of LLM products, and you want to deploy it on your on-premise environments or self-hosting environments, then you can definitely try this one. When it comes to LLM, rather than the computer vision or just those kind of traditional models, it's not enough to optimize the model itself. You also need to optimize the serving configuration at the same time, because the serving scenario varies a lot. For example, input sequence length, maximum input sequence length, or system prompt length, output sequence length, maximum batch size, or are we going to quantize the model into wait-only quantize for them, or activations at the same time? Are we going to use the speculative decoding or whatever? All of these kind of configurations are heavily depending on your workload itself. So there, again, a lot of cycles of experiment, deployment, evaluation. This kind of cycle has to be done repeatedly. That's what this tool can really help. So yeah, as I mentioned, for example, for some workloads, using VLLM would be not good. So instead of VLLM, if you change to a TensorRT-LLM engine serving framework, then you'll get like 2x cost efficiency in terms of cost efficiency and so on. Or sometimes in your workload, time to first token or TTFT latency is the major priority, or in sometimes TTFT is not that enough, not that important. We just need to maximize the throughput itself, so cost efficiency. So this kind of requirements or constraints depends on the workload service scenario itself. So it's very important to find the optimal serving options for your service scenarios. That's what we can help. So the platform itself also support a lot of experiment setting with different variables, and also designing and run the script for a bunch of experiments, analyze the results, and so on. This tool can currently support connecting the models from Hugging Face itself. So all the Hugging Face models can be connected automatically. And also we currently support VLLM and TensorRT-LLM for LLM serving frameworks. We are working on expanding more frameworks. And also we support all the NVIDIA GPU lineups, including the Jetson devices. And also we have worked with Intel Gaudi team for last year a lot. So we also support Intel Gaudi 2 devices. And when we were working on this kind of project, integrating VLLM was easy. But the thing was, it was very difficult to integrate the TensorRT-LLM frame pipeline with this toolchain because of like bad usability and so on. But the performance itself is usually better than VLLM, so we could not like give up the TensorRT-LLM because few of our customers want to deploy TensorRT-LLM on their service scenarios. So we recently open sourced a tiny project called Ditto, which is direct torch to TensorRT-LLM optimizer. So with the help of this library, open source library, we can now support, convert Hugging Face PyTorch models directly to TensorRT-LLM engine. So previously, to use TensorRT-LLM engine, you had to write the conversion script manually. So there is a bunch of predefined scripts for popular models like LLaMA, Qwen, Mistral, and so on. But if you are customizing your model a little bit in terms of architecture, or if there's brand new models from Cohere and wherever it is, then you need to write your script to convert that to TensorRT engine. But we didn't want that, so that's why we built this automatic engine builder library from PyTorch to Hugging Face. We extensively use the Torch to TRT open source project from NVIDIA. So if you're interested in, please check out this GitHub library also. And let's go back to our live demo of this toolchain. So this is the main page when you log into this service. Again, it's free. You can just log in and sign in and log in. We support multiple features here. So it's basically also managed by project. But here, you can connect any nodes, GPU servers also, from RunPod, AWS, or your on-premise servers, and so on. You can just run a Docker image provided by our side, then it's automatically connected. And it depends on frameworks. And also, you can also register a dataset from Hugging Face datasets to use for benchmark or evaluation and so on. You can also register any models from Hugging Face. So you can just describe the model repository link. It's automatically connected, so you can download the model from the Hugging Face and use it for benchmarking and so on. So with the model, dataset, and nodes, you can now set up any projects. So for example, let me show you one from this. So I wanted to evaluate which kind of GPUs to use for better efficiency. So here, let's see, a lot of different experiments with different configurations. For example, I fixed the model to LLaMA 3.1 8 billion instruct model, dataset fixed. I've varied the hardware with A100 and H100, and I've varied multiple serving workloads, for example, input lengths to output lengths and multiple configurations. You can also try a bunch of different configurations, which is supported by VLLM or TensorRT-LLM, and also for multi-LoRa serving, and so on here. But yeah, anyway, if you configured all the variables and click, benchmark, start benchmark, and it will automatically go to the connected node, download the model, download the dataset, and evaluate the performance itself. So for example, here you can see the throughput in terms of token per second per chip, and TTFT, TPOT, cost efficiency, and also how much the model weights takes in terms of memory and so on. Yeah, so based on this kind of information, you can choose, okay, in our service scenario, it's better to use A100 for serving this kind of application workloads. And so beside this performance evaluation, we also provide some quality evaluations. So for example, you can also activate Playground, which is supported by Gradio interface. So you can just wait for a minute. You can try it. You can actively chit-chat and how the model answers with those kind of configurations I set up before. And also, if you want to try a bunch of different samples, for example, a whole data set in terms of like MMLU evaluation, ARC challenge evaluation, and so on, you can also try that, register it. We have predefined data sets here. You can select that. And in the project, you can also, you can also see how the model, or with this configuration, with this input length, maximum input length, and so on, you can evaluate the quality metrics. So for example, here you can see the exact numbers and samples, how the model actually answered with its prompts. You can download it in CSV format, and you can see directly on the web page. So let's go back to, so Gradio demo is already up. So here you can, oh, who are you? Ooh. So it's basically Gradio demo with, so you can see the performance metric and quality evaluation by sample, considering the serving configuration that I clicked before in the lot of experiment lists. So with this toolchain, we support end-to-end pipeline for serving optimizations in terms of performance benchmark and also quality evaluations and so on. Yep. So I think this is it. Oh, last but not least, we have also recently published a lot of blog articles to leverage this kind of tool chains. So for example, we have extensive series of comparing VLLM versus TensorRT-LLM when you deploy on your self-hosting scenarios in terms of like specific techniques, prefix caching, speculative code decoding, and so on. So if you're interested in, please look at this, check it out, and see how those two frameworks work different on some experiments, and the numbers are already there. So you can take some know-hows and insights from this kind of blogs. Those are very important if you are considering moving from using just API to self-hosting for cost efficiency and so on. Yep, so I've run through a little bit fast, but oh yeah, the Fitron chips is for free, and for OwLite we provide today for 90% discounts promotion code. So if you purchase with this DevTools, the 25 code, you'll get a 90% discount for 20, I guess, peoples. So please try it and let us know which one should like improve or not. Yep, thanks.
All right, do we have any questions?
Thanks. What are the standard ways in which you measure the efficiency of a model?
Efficiency of model in terms of serving or not?
Let's say serving.
So yeah, serving. So it's just cost $1 per 1 million token generation is all. So it depends on how much you spend for like your GPU hardware itself. So for example, in the example I showed here, comparing A100 versus H100, when you connect the nodes, you can set up the price of your node. So for example, here I rented the A6000 device from Runpad, which cost $0.59 per hour. So you can consider this number with the throughput token per second. So how many tokens you can generate with this kind of configuration in this device. Then you can calculate how much you should spend for generating 1 million tokens. So that is one of our metric. And if you already have your node in your server farm, then it's just about power consumption and so on, right? So you just need to compare the throughput or time to first token and these kind of metrics itself. So basically, it depends on your workload and your environment itself. But for those who want to rent self-host their GPUs and then apply this kind of serving optimization, then it would be $1 per million tokens and so on.
So regardless of whether it's image classification or text classification or different use cases, that's the metric that you use, cost per million?
It depends. So that example for computer vision, image classification, or text classification, that's more likely for OwLite device, not OwLite products, not this LLM serving scenario. So in that case, well, we do not provide any specific metrics for efficiency because our customers usually have their own metrics to optimize. So that's what we also handle.
Any other questions? All right, well, let's hear it once again for Hyunjoon.
Thank you, everyone.